Today we're going to review solving quadratic equations by factoring. This is something you probably went over near the end of Algebra 1. Find the x-intercepts for the following function. If you notice, this is a quadratic function because if I multiplied these two binomials, I would get x to the 2, x squared, and it is a quadratic function in intercept form. So let's find those intercepts. P is 3, Q is negative 5. That makes our x-intercepts negative 5, 0, and 3, 0. There are some other names for finding x values of the x-intercepts of a quadratic, such as solve the quadratic. So if you were asked to solve this quadratic, the solution would be 3 and negative 5. Or find the zeros. The zeros of this quadratic are 3 and negative 5. Or you could be asked to find the roots. Your equation must be in standard form ax squared plus bx plus c equals 0 before you can factor. First and foremost, always look for a GCF, a greatest common factor. It'll make your life way easier, and sometimes you can't even factor further if you don't take out the GCF. We're going to solve each equation by factoring. First of all, we need to make sure it's in standard form, meaning it is equal to 0. Number 1 is equal to 0. Now let's look for the GCF between these two terms. The GCF is the greatest common factor between x squared and 3x. These two terms have an x in common, so I'll factor out an x. Factoring means dividing, so I'm going to divide an x from each term. We have to write this x in front because we cannot divide out an x entirely. We can only factor it. At this point, recall zero product property. We reviewed this in our lesson over intercept form. If a times b is equal to 0, then a is equal to 0, and b is equal to 0. We've solved this equation by factoring, and the answers are 0 and 3. For number 2, it's not in standard form, so we need to make it equal 0 first. If I can avoid having a negative on my x squared term, I like to do that. So I like to move everything to the x squared term side if the x squared term is already positive. The GCF of 2x squared and 4x is 2x. Divide each of these terms by 2x to get the new binomial inside. Now use zero product property to solve for x. And your answers are 0 and 2. How do we factor a quadratic when a is equal to 1? If you have a quadratic you can factor and a is equal to 1, this will factor to be x plus some number times x plus another number. The product of these two numbers is equal to c, and the sum of these two numbers is equal to b. So let me show you what I mean. Our product must equal negative 10, our sum must equal 3. Now you're looking for the same two numbers that multiply to give you negative 10 and add to give you 3. The factors of 10 are 1 and 10 and 2 and 5. So I'm going to use 2 and 5. I know one of those needs to be negative, but I can't tell which one until I look at the sum. Which number needs to be negative in order to result in positive 3? The 2. So you found w and z. Now you can factor to be x plus w and x plus z. Go ahead and use the zero product property to solve. So my solutions are x equals 2 and x equals negative 5. Remember, you can always check by plugging this in. Before I can use b and c for my sum and product, this needs to be in standard form. It needs to equal 0. So let's rearrange. Now that it's in standard form, I can find w and z. The product needs to be 6, and the sum needs to be negative 5. Try this one on your own, and then press play to check your answer. The factors of 6 are 1 and 6, or 2 and 3. So if I use 1 and 6, that could give me negative 5 if my 6 is negative. So my 6 needs to be negative. Oh, but 1 times negative 6 is not positive 6, it's negative 6. So that doesn't work. Instead, I'm going to use 2 and 3. Negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is positive 6. Be sure to check those signs as well. Write it in factored form, and use the zero product property to solve. For number 5, the product should be 9, and the sum should be -6. What could be your result? -3 and -3. Go ahead and write this in factored form. Guess what? We have a quantity being multiplied by itself. So we can actually rewrite this as this quantity squared. Using the zero product property to solve, you get the answer of +3, but you get that answer twice. This means this answer has multiplicity of 2. But we'll learn more about that in Unit 3. This quadratic factored into a quantity being squared, meaning this quadratic, a polynomial of 3 terms, is a perfect square. So it is called a perfect square trinomial. For number 6, my product should be -9, but what should my sum be? You could rewrite this as x squared plus 0x minus 9 equals 0. Then our sum would be 0. What two numbers multiply to give you -9 and add to give you 0? 3 and -3. Write in factored form. Use the zero product property to solve. The answers here are 3 and -3. This type of problem also has a special name. Right here, you have a difference because we are subtracting. X squared has something in common with 9. They are both perfect squares. This is called difference of perfect squares. X squared can be square rooted to be x, and 9 can be square rooted to be 3. Perfect square trinomials and difference of perfect squares always factor in the same form, so it can be helpful to memorize these forms for the sake of efficiency. How do we factor a quadratic when a is greater than 1? First, our equation needs to be in standard form in order for us to factor. Now I'm going to set up double cross. So here's how it works. These two numbers need to be factors of 2x squared. These two numbers need to be factors of 10. And after we multiply across the diagonal, blue times pink, our results, when added together, should be the middle term. Your factored form will look like this. Top row times bottom row. So let's begin with the factors of 2x squared. This time we'll use the variables in our factors. 2x times x is 2x squared. Factors of 10 would be, let's try 5 and 2. Now multiply across the diagonal. 2x times 2 is 4x. X times 5 is 5x. Do those add to give you 9x? Yes, they do. What are my signs? To get +10, 5 and 2 would need to be the same sign, so both positive or both negative. Because they needed to add up to be +9, these will both be positive. It's a +5 and a +2. So we have top row times bottom row. Now use the zero product property to solve. And we have our solutions for this quadratic equation when a is greater than 1. For number 8, let's first put it in standard form. We always want to check for a common factor. No, there's not a number that goes into 4, 8, and 21. So now let's use this method that we just learned. Most of the algebra teachers at my school call it double cross. Two factors of 4x squared, well, that could be 4x and 1x, or 2x and 2x. So you might have to try multiple options before you get the correct combination. But only if the 14x is negative, that would mean the 7 would have to be negative. And if the 6x is positive, the 3 should be the positive number. Check your signs. 3 times -7 is -21. 6x minus 14x is -8x. And now we have our factors. And then we can use zero product property to solve. x equals -3/2 and 7/2. And there is our review of factoring from Algebra 1.